Hello, I am Aditi Kumar and welcome to another conceptual learning session related to deep learning. This is basically a fundamental concept of deep learning, I can say, which is a preliminary step of deep learning neural network system. And it is known as Perceptron. We always basically talking about perceptron, neural network, artificial neural network, everything. But what exactly the foundation of this particular perceptron in artificial neural network? We will basically dig dive into that today. Let's start for today. So if I am talking about perceptron, I can say this is a building block of artificial neural network, and we already covered this concept in our last video related to deep learning, or it was a introduction to deep learning, that key artificial neural network is basically using the neural concept from human neuron. It is basically a artificially we are building the neural network, which is, I can say, the concept is derived from the neural system, I can say, human neuron, or maybe human neural network, human brain neural network. But actually under this particular perceptron, how are the things is working, or maybe what are the components coming under this particular perceptron model, right? So if I am talking about perceptron always, so I can say this is a very basic type of artificial neural network, and it is a simple type of neural network. And the main concept here is, so if it is a perceptron, this is a perceptron, then each input is basically connected to output directly, because this is a single point, single perceptron. This is not a, I can say, this is not a network, this is a single neuron, I can say. It is a neuron. Perceptron is a concept or conceptual mathematical concept of neuron, a single neuron, and a neuron is a part of neural network. So again, this is a single neuron. Each and every input is connected directly to output, or maybe directly, actually it is impacting the output, I can say. And basically this particular one neuron or one perceptron is ideal whenever basically it is easy to separate these two groups. For example, I can say linear separation. This is a group or this is a group, our data is like this, and we can just create a line to separate these two classes, right? So in that case, perceptron model is a ideal use cases, I can say. But what exactly this perceptron? The perceptron is a neuron which is a part of a neural network, and it is a foundational or fundamental building block of artificial neural network. Then what are the components coming under this particular perceptron? So if you will see here, this is basically the input layer, all the inputs, and in the inputs one is basically 1, I can say, and another is x1, x2, like this. I will explain actually what exactly that. Then each input is associated with some weights. Then again it is basically fed to a network input function, which is a summation function. Summation function, we are feeding into a summation function. I will explain actually the mathematical intuition later. And then finally output can be derived by passing this particular output through a activation function, and completely this particular activation function, it depends upon what type of output we are expecting or what exactly our problem statement. Let's understand the concept actually, each and every concept actually in with some wording. Here basically input feature means input represents the different aspect of the data, all the data basically we are giving. Weights means importance assigned to each input during processing. It is a weight, importance. summation function, it's add of input function. For example, here summation of xi wi equal to x1 w1 plus x2 w2 plus x3 w3 up to xn wn. This is the summation function. And activation function is decides a final output based on summed value. I can say there is a certain function, activation function, we are passing through this particular function to get the output, get the expected output. It is completely driven by the what output or what problem statement actually we are having, or the what output we are expecting. And output is basically our final prediction. It's clear. Then there is a concept actually I highlighted earlier, which is one, other inputs are x1, x2, x3 up to xn, but where there is a input which is 1, it is known as bias. Bias is basically an additional parameter which is used to adjusting the independently of input. I can say it is stabilize your model. It is used to add more stabilization into your model. That is basically the use of bias. So then finally your learning algorithm. We are basically as maybe each and every cases actually of the machine learning model or any model, there is a mathematical equation behind it. So which is basically we are trying to fitting that particular mathematical equation with the help of data, which process is known as learning algorithm. So adjust the weights and biases based on training data. Again I am explaining, we cannot change the input, we can only change the weights, which is known as parameter during our training process. So let's look into quite mathematically, I can say. So working perspective, I can say this is our input, this is our weight, right? Then this is our summation here, this is our summation here, summation. Then that summation is fed into activation function, then we are getting a output. Then we are measuring our output with reference to our validation data, or maybe some reference we are having. Then we are getting some error. Then we are trying to set our weight accordingly so that we can reduce our errors. We can minimize our errors and maximize our efficiency. That is basically the aim behind training. This is the training process. We need to set optimal W0 to Wn. This is the target during the training process. So the stepwise, if I can explain here how the perceptron actually work. The first step, multiply the input and weights, and basically this is the output. And that output actually, along with that output, we are adding a bias, as I explained here. This is B, and after adding this particular bias, or we can say this is W0, a bias. In the second step, an activation function is applied. I can say f is the activation function, this is a function, and we are passing, we are getting the output equal to output of wi, summation of wi xi plus b. That is basically the activation function. And during training, the perceptron weights are adjusted to minimize the difference between predicted output and actual output. The difference between predicted output and actual output is basically the error. And we need to set our parameter. I can say we have to set our parameter with a optimal value so that we can raise our efficiency, we can minimize our error, and it will basically the model should be, or maybe that particular mathematical equation should be that much of robust, so that with the unseen data it should work actually efficiently. That doesn't mean that whatever the data we are trying to using that particular data, we are trying to fit this particular equation, for this data only our equation will work. No, that should not be. Ideally it should work for all type of data, I can say, all same maybe type of observation with same categorization, I can say. We cannot give basically, there is a certain significance of the data, right? Certain characteristics of the data. We have to provide the data with the same characteristics pattern. We cannot provide the image data whenever we are training a model with some text data, but we can directly pass the image data. No, this is, it can be happen, but the thing is, whenever we are setting a particular mathematical equation, directly we cannot give that. We have to do some other modeling technique to make this particular functionality enable. But here there is a single mathematical equation we are going to fit, and during our learning process or training process, we are setting the optimal parameter so that it will be more generalized and it will work efficiently with minimal error. So basically, if I am talking about perceptron type, there are two types of perceptron. One is single layer perceptron and your multi-layer perceptron. The kind of perceptron can be learn the pattern that are separated by straight line. Simple. I can say this is a single layer of perceptron, means it might be the case a single neuron or multiple neurons is a single layer, but again this is a single layer. Here basically what happened, I can say there is a certain group of data we are directly separating using a straight line. And for this particular straight line, our single layer is working. Single layer of neural, it might be the case 2 or 3 perceptrons in that particular layer, but a layer is one. Then after that, our activation function, then basically the I can say the output. Then multi-layer perceptor is actually the neural network. It is the concept of, because neural network means it is a connection of neurons, right? So multi-layer perceptor is basically is much used for handling the complicated pattern actually in the data. Even whenever basically we are having a complicated pattern in the data, we can only use the multi-layer perceptron or a multi-layer artificial neural network to handle this type of data. It is very difficult to handle using single layer perceptron. Single layer perceptron, I think it is a very simple task. According to the functionality or use cases, these are basically divided. So let's summarize whatever the thing actually we explained. So I can say this is a perceptron and we are having x1, x2, and here your bias B, and you are having a summation. I can say it's a summation of xi wi, and here we are having some certain weights like that, equal to x1 w1 plus x2 x2 w2 plus b, right? This is basically your summation, right? Then finally you are basically having a activation function, right? This is your y. That activation function may be I can say it depends how we are basically the output we are expecting. Then finally y equal to f of I can say w xi wi maybe plus b, I can say. This is maybe I can say b I can separate here, okay, plus b, right? This is basically our output, but from here actually we are getting output, right? We are having a reference output, which is the actual output. We are comparing this particular two output. For example, our output is y, here basically y hat, right? So if I will explain here, so our error equal to y minus y hat, like that, okay. So during our training process, we need to set our optimal parameter. For example, wn equal to wn plus y minus y hat, if I am putting a learning rate new and your xn, like this. So this is basically the function, genetic function. I can say we are setting the optimal parameter, adding a learning rate, your learning rate, and this is basically our error, right? And this is basically, yes, definitely our input. So this is basically during our training, each and every time, each and every step actually I can say there is a certain cycle. After completing a particular cycle, each and every time it will be calculated, and finally we will see how the performance basically is getting improved. This is basically the maybe I can say beauty of during training of a perceptron model. But again, the perceptron is a fundamental building block of artificial neural network. I can say the smallest component of a artificial neural network is perceptron, and this is a very fundamental concept in artificial neural network. That's why before starting the any artificial intelligence, or maybe I can say any artificial neural network model directly, so I thought I will start with some perceptron, then maybe single layer perceptron, multi-layer perceptron, then maybe how you can design basically the a particular function. For example, a single neuron basically, or maybe single perceptron using for a straight line. Suppose we are having some certain maybe I can say there is a non-linear function, right? Like a basically a angle type function, right? In that case, how we will basically design our artificial neural network, right? So this is basically the concept, because you can add more neuron there, or add more perceptron there to handle this particular problem statement. Definitely we will have further sessions on that, but today basically that's why I thought actually I will start with some perceptron related fundamentals, so that it will be pretty easy later to proceed ahead for complicated topics. Thank you very much for watching this particular video. Please do subscribe my channel and share this particular video, and also please comment under this particular video, so that I can get the better idea about your expectations and your understanding about this particular concept. And once again, thank you very much for watching this particular video.